When you picture the four seasons, assuming you live in a place where the four seasons are a thing, you probably think of summer and winter as opposites. After all, one is hot and one is cold. And the rest of the year is this middle ground we travel back and forth through on our way from one extreme to another. In other words, fall seems like spring in reverse. But the reality, at least based on how we technically define seasons, is totally different. Because the astronomical system, which we four-season folk use for most things, defines seasons not via temperature, but via daylight. Over the course of a year, the amount of daylight you experience on a given day oscillates in what's basically a sine wave. This is how the hours of daylight change across the course of a year in the northern hemisphere. The places where the wave crosses this line are equinoxes, days with nearly equal hours of daylight and darkness. And the peaks are solstices, the days with the most and least daylight. These features are how we technically divvy up the seasons. And when you look at the seasons like this, you can see that it's actually summer that's spring in reverse, not fall. During spring, we go from equal hours of day and darkness to peak daylight. And over the course of summer, we go right back to equal hours of day and darkness, where we had started at the beginning of spring. The same pattern, but inverted, occurs later in the year. Winter is actually fall happening in reverse. But as clear as that is on the graph, it doesn't make any sense as far as how we actually experience the seasons. Winter doesn't feel anything like fall happening in reverse. And if spring and summer have the same amount of daylight overall, why is summer so much hotter? Well, just like it takes a while for a pot of water to boil on a stove, it takes a while for changing daylight patterns to have an effect on temperature. Daylight increases over the course of spring, but since Earth's temperature rises slowly in response, we generally don't have our hottest days until the amount of daylight has already started to decrease. And since the falling temperature lags behind the decreasing daylight, the coldest days tend to happen once daylight has already started increasing. Looking at the temperature graph, spring and fall are reverse versions of the same middle ground, and everything we experience about seasons makes sense. So why don't we just use temperature to divide up the four seasons? Well, compared to temperature, which can vary wildly from year to year, daylight is simply more consistent. Daylight is so predictable that we've relied on it for thousands of years to mark the passage of time and track annual events, like the flooding of rivers and the best time to plant seeds. That deep-seated relationship with daylight is probably why it came to dictate the transitions between our four modern seasons. Even if these days it's temperature, rather than daylight, that puts a spring in our step.